All right, for Algebra 2, we are doing 3-4 today, graphing systems of inequalities. All right, so we've done equations, now we're looking at inequalities. Our objectives are to solve systems of linear inequalities by graphing and identify the vertices, plural, of the region containing solutions to a system. Okay, so there's going to be more than one vertices in the region. That's going to, and we say it's containing. Okay, so like when we've done other inequalities, it's like above or below. This one's going to be more of a section sometimes. All right, so businesses examine supply and demand, and they perform what's called a break-even analysis to determine prices so that they make a profit. Okay, so they want a break-even point. So that's what this graph here is showing. All of this section here, okay, is loss. They're not going to make any money at that point. But then all of a sudden we have this break-even point. Okay, so everything in this region is profit. Okay, that's where we're making money. There is profit. And so you notice that we have two lines that overlap. Okay, so the first one is the total revenue, and this one on the bottom side is the total cost to make the product. So these are some, the dashed line shows the fixed costs, okay, that we have. And then there's the variable costs as well. But either way, it comes up to an equation for the total revenue has to be more than the equation for the total cost. So where they break even, you're not making any profit, you're just breaking even. And then everything above that starts to make profit. Okay. All right, so to solve a system of inequalities, we're going to graph each inequality using slope-intercept form and shade. Okay, you could also probably use x and y intercepts if you wanted to, however. Then we're going to find the area of intersection of the graphs. So you're going to need like 2 or 3 different colored writing utensils. So if you have colored pencils, it's great. If you have a pencil and a blue pen and a red pen, or a blue pen and a black pen and a pencil, whatever, you're kind of going to want a couple different colors to make it easier. And then 3, the set of points that satisfies all of the inequalities is the solution. But again, it's not just one point, okay? It's the set of them, like the set of intersections. Okay, so let me clear this off and let's start looking at example 1 to solve the system. All right, so again, we're solving by graphing these. So we have 3x plus y is less than or equal to 4, and we're going to put it in slope-intercept form. So I'm going to subtract 3x. So y is less than or equal to negative 3x plus 4, right? That's our equation. So that's what we're going to graph. So my y-intercept is at 4, 1, 2, 3, 4, and negative 3. So I'm going to go down 3, 1, 2, 3, and right 1. Down 1, 2, 3, right 1. 1, 2, 3, 1, 2, 3, right 1. Now I'm going to go up 3, 1, 2, 3, and left. 1, 2, 3, and left. Okay, that gives me a really nice line. It's less than or equal to, so it's going to be a solid line through those points. Okay, it is less than. Okay, so I'm going to shade where y, like pick a point, where is y less than? Oh, it's less than this direction, right? So I'm going to shade everything down here. Or to the left, kind of. All right, then I'm going to go with a different color, and I'm going to do my next equation. So I've got x plus 3y is less than negative 6. Okay, so let's subtract x from both sides to get it in slope-intercept form. 3y is less than negative x plus 6. Divide by 3. So y is less than negative 1/3 x plus 6 divided by 3 is 2. So now I'm ready to graph that. Yikes. I wrote all over this really darkly, so it's going to be kind of hard to see. Our positive 1, 2 is here. So maybe I should say that shade lightly. I can't really change my shading unless I use the highlighter. Maybe I'll do that next time. All right, and then I'm going to go down 1 and right 3. 1, 2, 3. It has the inverse. Down 1 and right 1, 2, 3. Down 1, right 1, 2, 3. I'm going to go up 1 and right 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. Pretty close. All right, this one is less than, so we have a dash line through there. Okay, with my arrows on it. And it's less than, so I need my y. Where are my y's less than? So it's going to be down below again. Okay, so I'm going to shade maybe like that. So where exactly is my solution? Okay, where is my solution? Okay, so the solution is where the red and the blue overlap. Okay, so I'm going to make that green or black here. So this section in here, just where they overlap, okay, that is your solution set. Okay, so it's where the red and the blue overlap is the solution set. So it's really kind of messy, right? Okay. That's it. You've got it. You've got your solution set there. All right, so let's try the next one. Okay, I'm going to start with my first equation. 3x minus y is less than negative 3. So slope-intercept form, we're going to subtract 3x. Negative y is less than negative 3x minus 3. Remember, we can't have a negative y, so we're going to divide by negative 1 on both sides. What happens when I divide by negative 1 to an inequality? Perfect. We flip the sign. So now we're going to have y is greater than 3x plus 3. Y is greater than 3x plus 3. Perfect. So 3 is my y-intercept. My slope is 3 over 1. So 1, 2, 3 up, 1 over to the right. 1, 2, 3 up, 1 to the right. I'm going to go back and do 3 down, 1, 2, 3, and 1 left. 3 down, 1 left. 3 down, 1 left. 1, 2, 3. Okay. I know you don't have to put that many points. It really just is a lot easier for me when I'm graphing on the board to get a straight line. All right, so this time y is greater than. So we're going to have a dashed line through there. Okay. And since it's greater than, we want to pick the point where y is above. Let me see if I can use my highlighter. Where is y above? Okay, y is above up here. All right. Then our next equation, oh sweet, it's already in slope-intercept form. Woohoo, right? So y is less than 3x minus 1. So my y-intercept is at negative 1. And its slope is 3 as well. So we're going to have 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Go down, 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. It is less than, so it's another dashed line. Okay, and we want where y is less than this time. Okay, let's see if I can change my highlighting color maybe. Okay, that gets me more blue. All right, I should have switched those. So where is y less than? Down below, right? So these are where the y is less than. So where is the point of intersection? There isn't any, right? So this one is no solution. My abbreviation for solution. No solution. You could say it's an empty set. You can use the 0 with the slash through it, whichever. But if there's no place where both of the inequalities overlap, then there is no solution. All right. I have to keep that highlighter. I feel like it looks much nicer. Okay, so these inequalities can be with any inequality that we've studied. Notice these are absolute value inequalities. Same thing. So you have to remember those skills on how to graph an absolute value. Do you remember those, by the way? Okay, so let's think back about these. With this first one, remember that the number inside the parentheses is your h value. Okay, your h value is what moves it horizontal. Like if you think about the original equation for an absolute value, right? It was y equals the absolute value of x minus h plus k. Okay, so here our h equals -2 because this is x plus. So our h is -2. So this means we're going to move it left because it's -2. That's an L, by the way. Kind of looks messed up. That just makes it look more messed up. So let's try again. So we're going to move it left 2 spaces and do our absolute value. So we're going to go left 2 for our vertex, and then we're going to do our absolute value. And it's a greater than or equal, so it's going to be a solid line. So remember, we just make that V up there. Again, okay, but we moved our vertex from the origin, we moved it left 2. All right, and it wants everything that's less than. So where are my y values less than this? Up here? No, down here. So my less than values are down here for this one. Okay. So in this one, our next problem here, y is less than the absolute value of x minus 1. Notice there's nothing inside the absolute value. So this value out here, sorry, I tried to change color. Value out here, this -1, is your k. Okay, notice before in our equation, it's plus k. Here we have -1, so our k equals -1. If our h told us to move left and right, our k tells us to move up and down. So this one is going to go down 1 from the vertex. Okay, so we're going to come to our vertex. We're going to go down 1. That is where the vertex is here. And draw your absolute value. A little bit of overlap like that. Okay. This one was solid, so that's why I gave it the solid line. It says y is less than, again. Hold on just a second. I had to double check. I apologize. This is a typo here. This should actually be greater than or equal to, which is why I was so confused, because I was like, that's not going to give me the right graph. So please change that for me, and so we can go back and look at this. Nothing else has changed because I caught it before we graphed. Everything else is still right. So when we're ready to graph, though, it does change it. So we want the y when it's greater than or equal to, where when y is greater than, my y's are greater than up here, or my y is greater than down here. Well, greater than is above, so my greater than would be up there. So where is my solution? Where's my solution set? Okay, so my solution set, whoops, pardon me. My solution set would be this area within here. Okay, is my solution set. It's because the area of overlap is my solution. Okay. Now it says, notice the points 0, -1. So we have 0, -1, and negative 3/2 slash 1/2. Negative 3/2 slash 1/2. That would be this point right here. Okay, form two vertices of the solution set. You may need to solve a system of equations when the vertex is not obvious from the graph. And this point, negative 3/2 over, comma 1/2, this one is not real obvious for you to pick out, but I'm going to show you some others when you really will have to work for it a little bit. Okay, because this next one will kind of make you work for it. All right, so let's look at example 4. Graph the system and find the vertices of the region representing the solution. Okay. Notice two vertices are easily determined, but one isn't. So we're going to have to solve a system of equations for the intersecting lines. So that's when we get there. But you can already notice that, wait a minute, back the train up, we have 3 equations this time instead of just 2. That is perfectly okay. Sometimes that happens. We're going to do the same things that we've been doing though. So let's get them in slope-intercept form. So x minus 4, let me not use black actually. Let's see, I started with blue before. So x minus 4y is less than or equal to 12. All right, so let's get it in slope-intercept. Subtract x. So we have negative 4y is less than or equal to negative x plus 12. Divide by negative 4. Y is less than or equal to, negative divided by negative is a positive, so 1/4 x minus 12 divided by negative 4 is a negative 3. All right, so there's our first equation. So it's going to be a solid line. Negative 3 is our intercept, 1, 2, 3. 1/4 is our slope, so 1, 1, 2, 3, 4. This is also a time, 1, 1, 2, 3, 4, to be precise. So that's another reason that I draw so many dots, is so that I can really see my point of intersection and not just be guessing at my point of intersection. All right, so I want where y is less than, so we're going to shade below. Okay. All right, next equation, x plus y is less than or equal to 2. All right, slope-intercept form, we're going to subtract x. Y is less than or equal to negative x plus 2. So 2 is my y-intercept. Negative x, I'm going to go down 1 and right 1. Or you could go down 2 and right 2 to make it a little faster. Or you could do 3. But again, I try to do so many points to make sure I'm accurate. Because see, right here, we should be able to see our point of intersection. All right, it's less than or equal to, so a solid line. We've got one point of intersection here, which is nice. It's 1, 2, 3, 4, negative 2. Okay, so hopefully you see that. I'm going to go ahead because we know we want that. Because it says to find the vertices of the region. So it might be a vertices. Okay, so let me go back to the shading part. So we want less than. So less than is below. Okay, so that's less than. So I could have been wrong there and where we, but we're gonna, because right, this part's shaded, so this is gonna be a vertices that we're gonna need. Okay. All right, and let's see, let's go with green. So now we have 2x minus y is less than or equal to negative 4. We need it in slope-intercept form, so subtract 2x. Negative y is greater than or equal to negative 2x minus 4. We want to divide by negative 1. What does dividing by negative 1 do, or by a negative do to the inequality? Good, it flips it. So y is less than or equal to 2x plus 4. Oh, Oh, you guys, no, I missed it. Oh, you're probably screaming at me, and you should be. Because this, right when I divided by -4, I didn't flip my inequality. Oh, so it should be greater than, oh wait, it doesn't flip there. Let me go back. So it's less than or equal to here, but when I divided by a negative, I should have flipped my inequality and I didn't catch it. Arg! I'm so sorry if you shaded your paper already. Because this blue part should not have been shaded, right? Down there. I am so terribly sorry. Now I get to fix my mistake. Ah, I'm not fixing it well though. Okay, so let me put my red back. All right, we notice this point of intersection over here was 4, -2. Maybe I should make that black. So if I go back to my blue equation here, it should have been greater than, so I would have shaded above the blue line. Huh, doggone it. I hate making mistakes. It's just so much work. All right, so now let's graph this equation. Okay, so our y-intercept is 4. 1, 2, 3, 4. Okay, I'm graphing in green. My slope is 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, down to, I think, 1, 2 over 1. 1, 2. It gets a little messy here. 1, 2, 1, 2, 1, 2, 1, 2. All right, and it's less than or equal to, so it's going to be a solid line. All right, so our next point of intersection that's really clear is this one. Okay, and that's at -1, 2, 3, 4. -1, 2, 3, 4. So this is -4, -4 here. So now we need to figure out some shading. Okay, so we want y is less than our green equation. So to be less than, we're going to shade below. Okay, so that's why I've given you another graph here. If you want to regraph it and just shade your solution so it doesn't look like a mess, but your solution is right in this region right here. Okay, that -4, -4, that 4, -2, and then this point, it's kind of hard to tell what that is. And that is the intersection, though, of our red equation and our green equation is where we need to know the point of intersection between. So, like it said earlier, or like it says up here, we're going to have to solve a system of equations for those intersecting lines to know what that last point is. There's a couple ways that you can do that. You can do substitution, you can do elimination, does not matter in the least. When you have it set up like this, y equals 2x plus 4 and y equals -x plus 2, you can set those equal to each other, right? Like if you replace this y with that y, you're just setting them equal. So you would have, well, let me go back. Here it says y equal, or y is less than or equal to 2x plus 4. And then here we have the y, so we're going to say, well, 2x plus 4 has to be less than or equal to -x plus 2. Okay, which you would think it'd probably be right, but we want to find the point of intersection. So we're going to make it an equation instead of an inequality, right? Those y's are equal. And then we solve. So if we add x to both sides, we'd have 3x plus 4 is equal to 2. Subtract 4 from both sides. We get 3x is equal to negative 2. Divide by 3. X is equal to negative 2/3. Okay, so how do you think we're going to find y? How do you think we're going to find y? Right, we're going to plug x into one of these equations. Doesn't really matter which. I'm going to plug it into this one. It looks a little easier. So our y equals negative x, so negative 2/3 plus 2. Okay, so y equals a negative negative, so that's 2/3 plus 2. All right, well, 2/3 is equivalent, is 2/3. 2 is equivalent to 6/3, right? So what's 2/3 plus 6/3? Good. So y equals 8/3. About to cut it off. So this last vertex is negative 2/3, comma, 8/3. And you might have to write those out somewhere else, right? Our solution, vertices, okay? Solution vertices or vertices of the region. So you might say vertices of the region are negative 4, negative 4, negative 4, 2, and negative 2/3, comma 8/3. These notes are super messy, right? Whew, super messy and long. Okay. I hope that you were able to get it all in there and had enough room for that last problem. And I will see you tomorrow.